Difficult. Anyway, fine. I hope it is visible to all. The screen is visible to all. We will start. Okay, we will start. Right. So we were discussing about the Varignon's principle. Before discussing the Varignon's principle, we have learned this term, that is moment. As far as moment definition is concerned, it is nothing but the force which is applied on a rigid body about a point, about a point, which we call it as the moment center. It will produce a rotatory type of motion, which we call it as moment. And mathematically, it is described in this manner: if force F is applied about a point, then the distance of that application of the force, line of action of the force, and the moment center, which is given as small d, this is a perpendicular distance between these two things. 1 minute. नहीं अभी क्लास चल रहा है 3:15. ठीक. Right. So this is what we have studied, and in this d is a perpendicular distance. Necessarily, it is a perpendicular distance, and based on this, we have solved few numerical examples. Now let us shift to few more numerical. Before that, we have seen Varignon's principle. Varignon's principle. And as per this principle, what it states, that moment about any point, let's say point O, due to any force, let's say F, it is nothing but equal to moment sum of the components of this force about the same point, like this. So this is the equation related to the Varignon's principle. And this we have discussed for the two-dimensional system, that is x and y axis. Okay. Now let us try to apply this Varignon's principle for a few more examples. As we have seen that one numerical was solved, wherein you could see that there were two different forces which were acting in this space, and this space was again two-dimensional space. And as per the information of the geometry, you have found out various moments about various locations, right? Now let us try to solve one numerical wherein the idea about this application of Varignon's principle can be learned. So let's see that. Right, so you can please note down the numerical statement, problem statement. Write down. Find the y coordinate. The y coordinate of point capital A. Y coordinate of point capital A, so that the 361 Newton force will have a clockwise moment, of 400 Newton meter, 400 Newton meter about point capital O, about point capital O. also determine the y-intercept of the line of action of the force. Y-intercept of the line of action of the force. So such information is given. This is the x and y axis. This is the point at which a force F is acting like this. Slope of this force with respect to this horizontal two vertical, three horizontal. This is given. This is the point A. This is point O. This distance, this horizontal distance, this is mentioned to be 2 meters. From here to here, this is 2 meters. What you are supposed to identify? You are supposed to find out, firstly, the y coordinate of point A. That means this location. Y coordinate of point A. This is what you are supposed to identify. Okay? Secondly, you are also supposed to identify the y-intercept of the line of action of the force. So let us go step by step. What is given in the numerical? That the magnitude of this force is first of all mentioned to be 361 Newton, and it will have a clockwise moment of 400 Newton meter about this point O. So this force is responsible for the development of moment about this point clockwise, and the magnitude is 400, right? So can I say that as per the given information, moment about point O due to F, this is 400 Newton meter. Do you agree? This is actually given in the problem itself, right? But it is not shown over here in the diagram. What is shown? The magnitude of the force and the direction associated to it. But this information is told in the form of statement. So that statement has been converted into some in the equation form, you can say. Okay? Is this understood? This is given. Now let us try to simplify this thing. This force is an inclined force. So first thing you should keep in mind whenever you find such kind of inclined forces and some information related to the inclination is given, in that case, what you need to do is you need to resolve this into components. So do you agree? If I convert this system into this, are they equal? Just let me know. I will be drawing the equivalence of this to be so. Do you agree this thing? Is this okay? It is one and the same thing, correct? Okay. So this is that point O, this is point A. So forget about this figure now. What we are doing, we are converting this inclined force into components. So once we do that, can I not write it like this? f cos of theta, and this shall be f sine of theta. So can you not identify this theta value from this given information? So let me call this angle to be theta. How much value do I get if 2 vertical and 3 horizontal slope is given for theta? Tan inverse of 2 by 3 कितना आता है वो? How much? 33.69. Okay, fine. So ठीक है. So you can substitute the theta value over here, correct? Now let us try to identify this y-intercept. Now, whenever you are supposed to identify a perpendicular or distance as a whole, if you want to identify distance or intercept value, in that case, you are supposed to make use of Varignon's principle. It is very convenient. Varignon's principle. So let us see how that convenience is all about. If I say I am using Varignon's principle, so there are 2 points about which I can take moment. But in your given numerical, you can see that the information related to the moment about point O is given. So let us try to expand that. Let us make use of Varignon's principle and take moment about point O. How it is expressed? Correct? This is how it is expressed. Now, out of this, what information is given to us? Moment about point O due to F. This is given. Clockwise moment is developed. That is again given. So I can write down the magnitude over here, and direction will be positive. So no need to write positive. It is understood. If it is not without, it is with it has no sign, that means it is positive term. So anyway, now step by step we will calculate moment about point O due to Fx. What according to you shall be the value for moment about point O due to Fx? So for that, you extend the line of action of this force Fx. Okay, like this. Okay. So I will say Fx into perpendicular distance. What will be the perpendicular distance associated to force Fx about point O? What should be the value? Fx into perpendicular distance. How much it should be? Yes, hello. Am I audible?
Yes, sir.
So can you please let me know what should be the value of perpendicular distance? See what I am doing, I am taking moment about point O due to Fx. What should be the perpendicular distance? Y suffix A, correct? And in which direction this force will rotate about point O? Clockwise. So this will be positive. Secondly, if I am taking moment about point O due to force Fy, I will write down Fy into perpendicular distance. So I am taking moment about point O. I will extend the line of action of this force. What is the associated perpendicular distance for y Fy about point O? This much? Yes, it is given as 2 meter into 2. But in which direction this Fy is rotating about point O? anti-clockwise, so this shall be negative. So very simple, you substitute the value of fx and fy by expanding this 361 sine of 33.69 and this is 361 cos of 33.69. So please substitute these values and let me know what is the value of fx. Is it 300.4 Newton? Please check. And Fy, is it 200.24 Newton? Yes. Correct? From this you can definitely get Ya. How much? How much is the value? I am getting this to be 2.67 meter. Please check. Whether it is positive or negative. Yes, whether it is positive or negative. Yes, this is the what you can say as per the required information. What you are supposed to identify? You are supposed to define identify the y coordinate. So this becomes the y coordinate of point A. Another thing which is asked is that you are supposed to find out the y intercept. Okay, so in order to calculate the y intercept, you are supposed to do one thing. You are supposed to extend the line of action of this force and see what should be this intersection. That is this much distance. Okay, so let me call this distance to be Iy. Iy is the y intercept of force F. Okay, so I need to find out this y intercept, which I am representing it to be I suffix y. तो कैसे find out करोगे? Based on this information, what I will do, I will redraw this figure. I will redraw this figure and it will be like this. I have extended the line of action of this force F. Let's say this is that point A. Okay, and let this be I suffix y, Iy. Iy, a distance from here to here. Okay, this is Iy. This is point O, right? You need to find out this Iy. Again, remember, whenever we are finding out or whenever you are asked to find out the distance, that means you are supposed to take moment, or in short, you are supposed to take or consider Varignon's principle whenever inclined forces come into picture. Okay. So again, you are supposed to consider the moment equation. Okay. So you take moment about point O due to F. Okay. Sorry. Moment about point O due to F. Right. So see, this F actually it is acting at this point A. But what I have done, I have extended the line of action of this force up at this point. Fine. So can I not say that this system is equivalent to this particular system wherein this is that location IY, and at this point what I have done at this location, I have resolved this force F into its components, that is Fx and Fy. It is one and the same thing. Do you agree or not? Yes. So as per the principle of transmissibility, what it states that whatever force is applied on any rigid body, that force shall continue to be the same along the line of action of the applied force. So you take any point, at any point, the magnitude of this force shall be constant. It will be F throughout. And because of which, at this location, at this point, or at this location, or at this point, what will be the force? It will be capital F. But since the nature of this force is inclined, so it will be into, resolved into components. So Fx and Fy, correct? So once we say that these are the Fx and Fy components, what we can use, we can make use of the Varignon's principle, that is this equation, simple, correct? And once we are substituting the values in this equation, then it becomes very easy. This is 400 equal to, now what will be the value of moment about point O due to Fx? Please tell me fast. Yes. Am I audible, students? Yes. So please let me know what should be the value of moment about point O due to Fx. Will it be Fx into I suffix y? Please check. Because what you are doing, you are taking moment about point O, and this is the associated force, and this is the associated perpendicular distance, correct? So that's why it is going to rotate about this point O in this manner, that is clockwise rotation. Am I right? What about moment about point O due to Fy? What should be the perpendicular distance in this case? 0. Excellent. Because this Fy, if you extend the line of action of this force Fy, it is passing through the moment center. Okay, and therefore this distance is 0. There is no perpendicular distance. And simple equation comes out. What is Fx value? हमने पहले Fx value find out किया था. What was that value? It was 300.4. So substitute that value and you will get Iy. Iy came out to be positive in this case, and that positive value is 1.33 meter above O. Above O because it is positive value. Okay? Is this clear? So let's take up another example. You can write down write down the moment of a certain force. The moment of a certain force, capital F, is 180 Newton meter. Is 180 Newton meter clockwise. Clockwise about point capital O, and 90 Newton meter counterclockwise. 90 Newton meter counterclockwise about point B, capital B. If its moment about point A is 0, if its moment about point capital A is 0, determine the force. So I need your attention, everyone. What is given? This is the system which is given. This is point A, this is point B, and the distances associated to point A and point B are 3 meter and 6 meter respectively from this point O. Okay? This is given. Other than this information, whatever information I had told in terms of statement, those are given. बाद में इसके बाद में कोई भी इंफॉर्मेशन दी नहीं है. No force. I don't know what is the nature of the force. I need to find it out. And what is the information which is with us? First information is that moment about point O due to certain force capital F, which we need to find out. It is 180 Newton meter clockwise. It means positive. This is clockwise. Okay? This is given. Second information, what is given? That about the same point O, about point capital B, a counterclockwise moment is getting developed. That is about this point B. Moment about point B due to same force capital F. This is counterclockwise. Counterclockwise का मतलब होता है anti-clockwise. 1 minute. Counterclockwise means anti-clockwise. Counterclockwise. ठीक है? Is this understood? So this is these two informations. Hold on. Given. ठीक है? Other than this, nothing is given. And these distances are mentioned about this point O. I need to find out what is the capital F. Okay? So I require everyone's attention over here, please. See, in such numerical where the force direction is not mentioned, okay, assume this to be an inclined force. Okay. See, I don't know at this point of time what is the exact nature of this force F. It may be horizontal, it may be vertical. I don't know. So it is very much judicious to consider this capital F or whatever force, unknown force, to be an inclined force. Okay. So where to keep this? Where to keep this force F? That is now is a question. Now see, there is one more information is given. What it says, that if its moment about point A is 0, if moment about point A due to force F is 0, this is again given, then you are supposed to find out this F value. Okay. So what I have done, I have considered the direction of this force to be inclined. Okay. And if I want to achieve this condition, where I should place the capital F? Can anyone tell me? In order to achieve this condition, where I should place capital F? Yes. Can anyone tell me? Perpendicular to A. Acha, perpendicular in the sense like this? Yes, you meant to say like this or ऐसा? अच्छा, अच्छा on y-axis like this you mean to say. ऐसा ही होगा ना? Correct है? Parallel to what? Now see, one thing you remember. When do we achieve this condition? When? Yes, that means the perpendicular distance is 0, or in other terms, the line of action of the force is passing through that point. Is it not? Right? So both these options are correct. So the force component, if it is passing through point A, if Fx is passing through point A, your equation is satisfied. Or force component, that is y component, if it is passing through again that point A, again this is getting satisfied. That means these two conditions are just fine. Okay, so prima facie we know, in order to achieve this condition, what I should consider is the line of action of the force F is passing through that particular point. That is for sure. Okay. Now next is, I don't know exactly what is the nature of this force F, whether it is vertical, horizontal, I don't know. So it is very much desirable to consider the force to be inclined. Okay, so what I will consider, I will assume the force to be acting like this. Okay, what I am doing, I am assuming this force to be an inclined force, and it is acting like this somehow. Okay, this is not the final uh, output. This is what I am assuming, right? But while assuming, I am making sure that this condition is getting satisfied, isn't it? So what I have done, I have passed the line of action of this force from this point A, and therefore my condition is getting satisfied. Now next conditions, whatever are given, let us try to make use of these conditions, and with the help of all these three conditions, let us try to find out what should be the value of capital F. So did you get my point, what I am trying to explain you? Are you able to understand it? Did you get it? Please let me know. Okay, this condition is given. Okay, based on this condition, what we have done, we have identified the preliminary location of force F. Right now I don't know about the direction. I don't know whether it is inclined, horizontal, vertical, I don't know. But I am assuming that it is inclined in this way. Again, this inclination, whether it is true or false, that is again not known. That output will be, we will get that output when we will make use of all the three equations, whatever are given. Okay, so let us try to make use of all these three things, out of which we have already considered this. Now let us try to make use of this thing and this thing, right? So if this is the case, don't you feel that this situation is same as this one? This is point A, which is 3 meter, and this is point B, 6 meter. These two things are equal, don't you feel? What I have done, I have resolved this into components. That's it. Correct? I don't know the inclination and all. Nothing. Okay? So let us try to find out everything in terms of fx and fy, and we will get something, right? So let us try to find out. So if I am doing this thing, fx and fy components, then I will make use of Varignon's principle. Okay? Let me consider moment about point O due to F. This is the Varignon's equation or Varignon's principle, right? Fine. So moment about point O due to F, what it is given? It is 180 Newton meter, which is clockwise rotation. Now, based on our assumption, moment about point O due to Fx, what should be the value? Fx into 3, am I right? Correct? Similarly, the direction will be positive because it is rotating in the clockwise direction. Now, I will be finding out moment about point O due to Fy. So do you appreciate that this value will be 0? I will be directly writing down the values now because you have understood the concept. If I extend the line of action of this force, it is passing through the moment center and therefore this value will be 0. Do you agree or not? So based on this equation, what value of Fx do I get? 60 Newton, and this is coming out to be positive. That means the direction of component Fx, it is positive. Okay, based on this information number 2. Let us try to make use of information number 3. Okay, what is that information? Moment about point B due to F. Should I rub this part? This is understood to all. I will be writing down the equation over here. Moment about point B due to F. Fx, Fy, B. What is the value? It is minus 90. Okay. This is Fx, Fy. Fx, Fy. Moment about point B. Where is this point B? Over here. Okay. Because of Fx. Now extend the line of action of this force. Drop a perpendicular in order to find out the perpendicular distance small d. What is this value? How much this should be? 3 meter. Excellent. This is Fx. Okay. So Fx into 3 meter. How it is rotating? It is rotating in the clockwise direction. So this is positive. Then moment about the same point B due to Fy. Now, in order to find out that moment, what you do, you extend the line of action of the force, right? And you drop the perpendicular from this point B to this point, or on this line of action of force. What is the distance? 6 meter, okay. And in which direction this is rotating about point B? Again clockwise, correct. So Fy into 6. Very good. Now what we know? We know the value of Fx to be 60. Is it not? Substitute that value over here. 60 into 3 plus Fy into 6. This is minus 90. What value of Fy do we get? Minus 45 Newton. Correct. That means Fx was positive value, whereas Fy is negative. That is, whatever we have assumed is incorrect based on the information given, and therefore the direction of this Fy, it should be in the downward or opposite direction. Okay. So the final picture, if we want to represent the final picture associated to the components of your F, how it should be? Fx should be positive like this, and Fy is negative 60, 45. But mind well, these two are the components of the force. These are not the final values of force. Okay, what will be the final value of force? It will be nothing but the resultant of this. Do you agree? And in order to find out resultant, what do? We make use of this equation, which speaks about summation of forces in x direction square and summation of forces in y direction square, and its under root value will be nothing but the resultant. So how much does this come out to be? Yes, what may be the value? 75 Newton. Okay, and since it is a vector quantity, it should have a direction also. So tan inverse of 45 by 60. How much? Correct, 36.87. So whatever was our assumption related to fx, it was correct, but the assumption for Fy was wrong, and basically the direction of this force, which will be acting at this point A, will not be what we had anticipated, but it shall be now like this. This is point A, suppose. So it is acting like this. Okay? Is this understood? Is this understood to all? Okay. Okay. So such kind of numerical you will come across. So in order to find out solution related to such unknown forces, you are supposed to follow these simple steps. And while following this equation will be very much helpful. Okay. And you are supposed to make use of this equation, basically Varignon's principal equation. Okay. So in the next class, we will see a few more examples, and we will then shift to a new concept. which is again related to the moment equation, right? So I will stop here. Thank you.